Hello and welcome to another episode of Invalid Entry. This is going to be a little micro-series playlist amongst the other things that we deck out the shed and the cyber shed series and the big screen stuff that are going on. We're going to call this Nerd Sniping after Randall Munroe, who a few years ago, many years ago now, made a web cartoon which was about propping up problems which cause people to stop and go, hold on a second, I can solve this. They're usually really subtle problems which don't necessarily have the output, or the solution may be much more complicated than you realise. So it's currently Friday the 28th of August. I'm on holiday, which is, again, this extra special video. I'm waiting for a wood delivery so I can do some building. 10 days ago, Norfolk Developers posted this, which is the first expression is correct, the next one is not so correct. It is syntactically correct, it just doesn't give you the answer you expect. It is a JavaScript challenge, and for those of you who know me, it goes without saying really, but those of you who don't know me, I do not give JavaScript the respect it requires, mainly because it is JavaScript. It is obviously from the name Java, which I know Java 1.2 rather well. Java hasn't come on much since 1.2, right? And it's got the word script in the title, which means I don't need to bother learning it or respect it as a language, because it is just a scripting tool at the end of the day. First of all, though, we're going to deal with this in Python. So I just want to check it works. So this is, I've just copied into a JS fiddle, because obviously I have no JavaScript development tools on my computer whatsoever. So here we go. 2 is less than 3. 2 is less than 3 and 4. So this should print off true. This should print off true. 3 is bigger than 2, so yeah, that should print off true. And 3 is bigger than 2, and 2 is bigger than 1, so that should also print off true. And when we run it, down the bottom here, you can see it goes true, 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 and obviously the last one is definitely true as well. So JavaScript, perfectly good language, obviously. There is the issue. If we move over to Python for a moment, I can do 3 is less than 4, that works fine. 3 is less than 4 is less than 6, works fine. I can put that backwards. 6 is bigger than 4, works fine, and 6 is bigger than 4 is bigger than 3, or 3 even, also works fine. In fact, Python doesn't have the same problem JavaScript has. The answer is, first of all, this is where the nerd sniping happened. I'm sitting there going, okay, because I understand how Python works under the hood. I understand how the objects call a function on the object because of the dynamic typing of both languages. This could be interesting. Now, I then had to learn JavaScript, is the first admission for this. In the research for this video, I had to learn a lot about JavaScript. My kind of first assumption was that if I make this A equals 3, B equals 4, C equals 5, or whatever, then in the abstract sense, this is still valid. So my understanding of this was basically calling an internal function on the object. Now these would be integer objects. So I would go A dot is less B, like that. But my understanding was actually it would then actually almost put those inside of. So it would actually be calling something more like is B dot is less, or let me construct that correctly. B is less than C is A dot is less than B and C. And this is probably backwards because actually it's going to do those two first. So that's actually not what it's going to do. It's going to do A dot is less B, and then that, the output of that is going to be dot is less than C. Now when you think of it like that, it kind of makes sense why it shouldn't work, because the output from this isn't a number, it's a true or false. And then this won't have, or won't be able to do a is less, because true and false doesn't have an is less. Yes, you could say a true is a 1 and a false is a 0, and therefore you could calculate it out. But actually no, it's a different type, so you should get a type error when you try and compare the two together, or you get an unexpected output. And that's basically what we think is going on here in JavaScript, is that in this case you're comparing the output of 3 is greater than 2 to that, and that is where you get a different value. So this always comes back as 1 or 0, then it will be bigger than the answer. And the real question is, if I put that to -1, do I then get an answer which makes more sense? And the answer is yes. So that sort of supports that theory, that this answer here all depends on the last value. If that value is 0 or less, and these values are bigger, then you'll get the correct answer in JavaScript. But if I then extend this to go even further into 4, 5 or 6 expressions, then it goes wrong. And it only goes wrong on is bigger than, because on these ones, basically what you're going to say is, it actually will go wrong on these ones as well, because this one will equate, assuming this one's going to equate to 1, the output of that function is 1, and then 4 is bigger than 1. So if we make another line here, which here is -5, 5 smaller than -3, now it says there is smaller than -2, so that should give us a true answer. And I suspect it's going to give us a false. And there you go, nice false answer. So it's got nothing to do with the size, to do with the fact that it's calculating the answer of that and putting that answer, comparing that result there. Just to check that in Python, if I go back to my first example here, is -4 smaller than -3, -2, and the answer is true. Now, this is where it gets fun, and let's start looking actually what Python does first of all, because I know Python very well, and then let's look at what JavaScript does, because they're actually fundamentally parsing this sentence in a different manner. Before we do that very quickly, people say, why would you ever want to put more than one equality in a sentence? Well, it's a design pattern actually. I probably never want to put this way around. I don't like things going bigger to small in that direction. There are some instances where I've done it, but a design pattern in Python, a really easy one, you may have some input data is equal to, I don't know, some user inputs, let's say 32. And then I want to say in a validate function, is input is the minimum small or equal to the input smaller than the maximum, like that. So this I don't have to do in JavaScript. What we've discovered here, especially as minimum, if it's a setting, could be a negative number. Like what's the minimum, I don't know, sea level that you're from, mean sea level, that could be a negative number, maximum number. You would have to do is minimum less than or equal to input, and is input less than maximum. You'd have to do something like that. That would be the equivalent. But this actually reads nicer. So when you've got a whole bunch of comparisons that you're trying to do, you might even want to say something like, I don't know, you might want extra validation steps where you've got multiple 4 or 5 things in a row where you're saying, is this choice less than this choice, and are they between this range? You can do those kinds of things in one query, and it looks right when you're trying to read it, when you're trying to debug it. So that's why I want to be able to do 3 or 4 part lessons. The Python method allows me to do any length and it gets it right every single time. So we're going to skip to Python. Okay, so what we have here is a class called silliness, because I usually I'm going to call a lot of my classes silliness. This is a silly class, and what I've done is I've given each silly object an identity and a value, because we're going to compare the values, but I want to know which one is being compared with what. I've implemented the less than, or I've overridden the less than operator and the greater than operator, so we can now print these off. I created 4 silly objects, A, B, C, D, each one increasing in value, so we know A, B, C, D on that order when we do the testing. Let me actually run these 2 functions. There you go, we've got these in memory. So I can now do A is less than B, and it will tell me I'm printing off the item which is being called and the item it's being compared to. So you can see here it's comparing A with B, and A is smaller than B. Just to check this, if B is smaller than A, it says comparing B with A, it's returned false. Okay, so this works as a little test rig. So we now do the first test. It actually does 2 comparisons. It's comparing A with B, and then it's comparing B with C. Now we can't actually tell whether it's comparing the result of those 2 together, because the result of those 2 things are both true or false. You can't actually tell what the output is. I could in here return another silly object which will tell us if there's another comparison going on. There isn't. I will just tell you that now. The point here is that it is definitely doing an A and B comparison, and then it's definitely doing a B and C comparison. That is a fact, but we will prove that with 1 step further. Just in case you were worried, if I put a D in there as well, just in case you're worried, in fact I'm going to go back around the loop and put an A and then go put another B in. What you'll actually see here is it compares A and B together, then it compares B and C together on the next line, then it compares C and D together, then it compares D and A together. but it doesn't compare A and B. Not because we've already compared A and B, don't jump to that conclusion, it's because this has returned false. So it's skipped. And this is to do with the order of operations in Python. There's a very cool thing you can do if you have some kind of settings or some kind of user input which may have, let's say it's JSON or it's an API, and you don't know whether it's a dictionary of some kind, and it's got like or it's an array. You might have an item. You can basically do a thing here where you can say, oh no, it's a dictionary. Sorry, my examples are going sideways already. Let's version 1.0 like that. Something cool. You can now say if version in dict.keys, this should be data. Data.keys. You can sort of do this and version data version equal or is greater than 1, 2, so, yeah, whatever you want to do. If for some reason your very old ones didn't have the version flag and it was something you added in later, basically if you just had that, if the version was greater than 2, you'll get a key index error, which would break. So this basically means that if this comes back with false, it doesn't bother executing anything else in the rest of the statement, which means you can do very cool wrappers like that. And it's that kind of optimization going on here. So basically it gets up to there and doesn't do any more. But you can daisy chain these together for as long as you like and it will give you the same answer. To prove that definitively requires an understanding of the Python language. And this is where it gets maybe a little controversial and maybe a bit of understanding of what the Python language actually is. Python is a compiled language. It compiles down to a bytecode. I'm still trying to work out whether every single implementation of Python has to. It seems like it on the surface it does, because some of the Python definitions talk about the bytecode. Some of the implementations in the spec say, oh, this is a C Python standard, or this is the output depends on the version. So if I say, give me what the bytecode instruction values are, they differ from interpreter to interpreter, but it seems like everything would have to actually create a bytecode under the hood just because of how some of the functionality work. In contrast here, Java does not define that. Java has a much better language specification, which actually means you could implement the language in other ways, which, again, I learned this the last few days. Basically, there is the V8 interpreter, which is, ignition and turbofan and things like that. And that's going to have an impact when we try and establish what's going on under the hood in the JavaScript version. So I'm going to take apart this bytecode here. This is where the geek level, the nerd level, go straight to the roof. So I'm just going to import this. Okay. With this is the inbuilt Python disassembler. It's in the language spec, and again, this is where it gets really interesting. If you have to have this in the language, does that mean you have to have a bytecode? That's an interesting question, really. So dis .dis, I'm going to give it a code block here of A is less than B, is less than C, is less than D. Actually, I'm going to start with A is less than B first of all. Now, that is the bytecode for it, and it's a really simple bytecode, and it requires now a bit of an understanding of how Python works. So I'm just going to open up an editor so I can actually do this in a graphical sense. Okay. First of all, Python is a stack-based language. What that means is that we add items to the stack, and then functions will pop things off the stack when they run the function, as opposed to other languages and other machine code languages. For those of you who don't know the difference between the bytecode and the machine code is what goes into the processor and is very dependent upon the electronics in the processor. Bytecode is a virtual machine language, and most modern languages are actually virtual machines. And that's important because when it allows you to do stuff in the processor electronically, which is much cooler, like out of order instructions and recompiling on the fly for multiple threaded and do cool stuff. Things like the Italian processor are really, really cool. Virtual machines are definitely the way forwards, but not like you think, oh, I'm running parallels and I'm running Windows inside Linux or Linux inside Windows. Virtual machine languages are super, super important. So we have a stack. So what's going on here, and I realised that's right underneath my camera, so congratulations me. Let me just move it up there, is we have a series of instructions, and this bytecode that's been exploded by the disassembler to actually give me elements. So the first thing it's going to do is going to load 2 values onto the stack. So what it's going to load first was A, and then the next thing it loads is B. Because I've said is A greater than B, the next thing it's loaded is B. Okay, so you now got A and B on the stack. Next thing it's going to compare. So compare, I just happen to know, compare will pop 2 items off the stack, so that this is basically at time statement number 4. And the reason why the statement numbers matter is because they're the number of bytes long, because you have a number of instructions that you go do and so on. So what then happens is at the compare, it's going to pop those 2 off the stack and return the result, which is going to be true, false. That is now the only thing on the stack, because we popped 2 items and put 1 thing on. And the next one's going to return the item, which is going to return the topmost item on the stack, true and false. Okay, so that is done. Job done. Easy to understand. If you haven't kept up with me, go over that one again. Now, what's more interesting now is if we now do A, B, and C, we get a bit of a bigger function. Now, you may think, oh, okay, it's going to do something slightly different. What it does here is quite interesting, in my opinion. I'm not going to write it outside, so I'm going to go upwards. So basically, the first thing it's going to do is go load A and B onto the stack. The next line here, I apologize, I've got messages coming in. Next line here is going to duplicate the top entry. So it takes B and it puts another reference to B on the top. And duplicate isn't actually, it's not duplicating the value, it's actually duplicating the references. These, again, virtual machines, these aren't hard values in the system, and we'll talk about that in JavaScript as well. They're not, like, registers aren't quite the same as the accumulator registers in an actual processor core. I've got airplane go ahead. So all these noises. The other day it was wind, now it's airplanes. So okay, we're up to here, we duplicate the top. Now, I don't want to... This is clever. I love this. When I found out it did this, I thought, yeah, it makes it scalable. What it now does is it now does a thing called ROT3. Now, ROT3, basically, the outcome of ROT3, before ROT3 it's that, the outcome of ROT3 afterwards is it takes the top one down and drops it to the position 3. And it does that even if there was other stuff underneath that on the stack. It drops the first item into position 3. Mainly you want to do these 2 back to back. Now it calls the compare op. At this point you'll have B at the bottom because the compare op takes 2 things, and you will have true or false. Okay? In the top slot. That is the outcome as we are in point 3. I'm just going to try and just close my messenger down fully. Okay, so this is where the state we are when we get down to this compare op. We've compared the top 2, we've got true, false. Jump if false or pop basically says if this is false, jump to the output function, where we're basically just going to go straight to the exit. And that's what caused it to skip the rest of the comparisons if you hit a false. So the first time you hit a false, we're going to jump to the end, call it quits, and then return the fact it's false. Because you know the false is on there, you can then basically return the top. However, let's assume it's true and we're going to continue. So if it's true, then basically this function is jump false or pop. So if it's true, that gets popped. So we're now left just with B on the stack. Now we load the next item on, and we load C. The next item always go on the top of the stack, so now we're stuck with CB or BC, and then we do a compare op again. So the compare op will pop 2 things off the stack and put 1 thing on. So at this point, we're left with true. We now go straight into returning that value in the stack. And in fact, what's nice about this is that this basically offers us a repeatable element. These 3 lines here, load, load, duplicate, rotate. At this point, we can basically load, duplicate, rotate, compare, jump. Load, duplicate, rotate. These 5 lines will be repeated. The first line you have to load to get the first value in. At the end, you don't need to do another load because you win at the end. So if I go on to A is less than D, is less than A, is less than B, is less than C, the compiler might be able to step in here. It can't. And this is, you might go, okay, the compiler should just go, this would never be true. If A was less than B, it can't be less than A itself. It should step in. It can't, because someone might have done something really, really evil here where they've changed the value on the first comparison. So you don't know at the outcome of running this that this isn't actually true. We could make this return true. You don't actually know it's just going to return true anyway, not even do a comparison. That's the thing. So here we go, much longer function, it's going to calculate all. And as you can say, at the start we have 2 loads, and then we go into this load duplicate top re loop, load duplicate row 3. So all that's doing at this point is saying, if at this point, what it would have done is duplicated the top value, so it'll be A, B, C, C. It would then have rotated that value, so we would then go up 1, C would be there. We'd then have compared, which means those two get replaced with a single value of true, false. That gets compared, that gets popped, and then we load the next value in. And we go around that loop again. Really easy to understand. It means Python work, and it doesn't matter if it was less than or greater than here. All that's going to change in here, and in fact you can mix them up when you do the compilation step. All that's going to change is whether it's a compare op or a compare op or a compare op, because the second byte, the reason why these two parts, the second byte actually tells you which compare op you're doing. Very simple, very easy to understand. Now let's go look at JavaScript. Oh, before we do, the main thing here was it proves the original statement that we had in the previous version here, that you're not actually doing what I outlined, what I suspected, where you're calling the one, taking the output of that and putting it into the output of the second one. It's proof Python does it correctly, comparing each pair of numbers in the sequence very efficiently. Okay, JavaScript. First of all, I don't know anything about JavaScript, or at least I didn't know anything about JavaScript when I started down this rabbit hole. I knew that JavaScript wasn't originally called JavaScript, it's called ECMA script, and actually ECMA script actually is the standard for the language specification, but in itself it doesn't actually describe how you should necessarily process or create a thing which then executes the language. Which I like. I do like languages to have formal specifications, which everyone thinks, of course you should have a formal specification. PHP for many years didn't have a formal specification. It just what was, i.e. if you wrote a bit of PHP, the output that it gave you was the output it gave you. It wasn't defined by mathematical saying. You couldn't say the output was right or wrong. Whatever the output was right, because that was how the language was described. It was literally as was. Whereas here you've got an ECMA script language specification which has no mention of actually any source code whatsoever. So you can sit there and go, if I wrote this hypothetical program, it should give me this hypothetical output, and you can actually validate that the interpreter is correct or not. With JavaScript, there are multiple interpreters, some newer than others. The one that I think is the most widely recognized is the V8 interpreter, and probably most JavaScript people have never even heard of it or probably don't know what it is. But basically it's the one Google have written, and it's behind Node, and it's behind Chrome and Firefox and a whole bunch of other stuff. And basically it uses multiple names, and it takes code and parses it and uses Ignition to make bytecode and use that. This blog actually is quite good because it does talk about there are some other versions. Actually, there's another thing down here. So there are different versions of V8 which allows it to both interpret it on the fly and also allows you to do full compilation and other things, which is going way beyond what we need to do. So what I'm going to do is I'm going to use the V8 as the rule of what JavaScript's doing, because that would make the most sense in this context. It would be interesting to know whether the initial challenge of JS Fiddle, which I suspect is using V8, I think it's running in the console, it might be running remotely, I can't remember how JS Fiddle works, but basically I'm going to assume this is running V8 and therefore is valid for the original question, but there may be other interpreters. The question really is, when we try and find the rule as to how it works, dive into that may be much harder, because in here I did try and find it in here where it would be, and then I found some really cool stuff that JavaScript has which Python doesn't, like additional things when you pre-add, so x equals +1, that kind of thing. You can't do that in Python. I'm not necessarily a bad thing, but it's just occasionally I want to do it. Anyway, we're going to switch to JavaScript. So we've got the JavaScript here. The first thing was to understand how to decompile JavaScript. Okay, so I thought I would start on a really simple bit of JavaScript. Console.log hello world. Someone's going to tell me there's an easier way to print. There has to be an easier way to print. It's very Java-ish, you know, system.out.println, but and apparently what you do is you just do, let's just take it works 1.js. I hope I'm in the right folder. Yay! And the program works. I can write JavaScript. I am now a professional JavaScript programmer. People just hit unsubscribe at that point, didn't they? So here what we're going to do is to compile it. Apparently you do this. You do print bytecode. And it produces you a short amount of code. Now, I actually know why it does this. It's because you're actually getting the entire engine to be able to instantiate things like the output to the OS and all the rest of it. I actually don't care about most of this. In fact, I believe all I care about is this last tiny bit of code here. And we'll prove that here. Now, I'm just going to take that bit out for a moment. What's really interesting is the compiler is actually quite cool in this, because if I do this and then scan that output, there is no reference to foobar at all. Absolutely none. So to make sure I could find this function, I put it inside of a function. I then call the function like that, and then I should now be able to find that function in here. And lo and behold, it's a lot of output. So what we're going to do is we're just going to... Oh, I'm not even running one. Let me run two. Lo and behold, it is actually very near the bottom here. And what I'm actually going to do is actually going to... There we go. Generated bytecode for function foobar. That is the function that we're going to look at. And it on the surface, it doesn't look too complicated. So what I'm going to do is I'm going to dump it to output text, so that we can actually look at it in here. And as I say, we don't care about all this leading code. We just go look at the bottom. And again, the decompiler is really nice. Let's be positive about it. It's given me the actual bytecode. I believe these are probably the memory locations looking at it, which is nice. These are the actual bytecode. The disassembler for Python doesn't do that. It just gives you the nice name for it. But this gives the nice name. It gives the arguments. Now, JavaScript is a register-based language. Register-based languages are different. They are harder to write machines for, but they are more powerful when you do. One of the things Python is so easy to write a interpreter virtual machine for the bytecode is because it's stack-based. You don't need to worry about, when you're compiling, about what you put in what register. When you make a register-based language and make a compiler for a register-based, or a high-level language to a register-based languages, you have to start working out where's optimal to put things in what register. In JavaScript, you have a register called the accumulator, which is your general purpose register where most functions will use that. So when you're doing a comparison, you're generally comparing one register against the accumulator. So what we want to see in this function compared to the actual input, we put the input on one side, is I want 2 to be in the accumulator and 3 should be in a register. That's what we should be seeing here. Now, the bytecode here is a little bit hard for me to read because I'm not a JavaScript developer. I don't look at this. I don't look at Python bytecode that often. But basically what they're doing is we're loading LDAs, loading into a register, the A1 value, which is going to be the second value I passed in. I think that's argument 1, maybe. And then we're going to test less than is, we're going to call the A0 value, which should be in the accumulator now, and we'll get output. And then we're going to return the output. Nice and simple, makes sense, no problems whatsoever. If I now do this, pass in more variables. Now what's interesting is the function isn't, the compiler isn't quite clever enough, again, for the same reason that it is clever enough. The compiler doesn't try and optimize this out. Once the function is encoded, it doesn't go, it's only ever called by 2, 3, and 5, and they're hard code those values in, because they could be flipped on the flight. This is where it gets a bit more fun. And I'm going to have to look this function up because I didn't prep this. So I'm going to be right back after this commercial. Okay, so I found there's actually an extra argument you can pass, it's probably off the screen here, print and code verbose the output, so I can put the output elsewhere. It gives me slightly more verbose output. And as we see in line 24,500, that I've got slightly better words. So ignore stack check for the moment. I don't know what stack check does, but it seems like you have to do that on the top of every function to make sure that you've got a valid stack. I think that's what it's doing. I don't really know. Loading. So basically, what in JavaScript, you have registers rather than stacks. So basically, we've got the accumulator, and then basically you've got a stack of registers are 1 through to whatever. So I'm just going to go 1, 2. That's an arrow. 3, 4, and so on. So basically, these are my registers that we're going to be playing with. The first line here, and I'll try and get these side by side because the first line here is basically going to load the A1 value. I think A1 is the argument value. That's going to load into register 1. Maybe register 0. No, these are anyway. It's going to load it 1. So it's going to load the arg1 in, which we know is B. I'm not completely convinced I know why. I think because arg0 is arg0. It should be in there. I think that's a bit of JavaScript I don't really understand. Again, I only started looking at JavaScript very heavily yesterday evening. And basically what it's now going to do is going to test to see is this less than this. That's the output. And the output from that will go into the general accumulator. So this will be true, false at this point. Okay? Not a number. It's not these inputs should be numbers or objects, where the comparison is. This is definitely going to be a true false type at this point, a Boolean type if you like. Star, which I had to go away and look up, and again they this is how you go and look it up, is you go find this interpreter generator CC for the V8 engine. You go down, a star is actually store and register operand at index, obviously, which basically means it's going to take the output from there, minus saying is, and it's going to stick it in R0, which I don't have. R0, there we go. So it's going to stick that Boolean in there. And then it's going to actually load the argument 2 into over here. It seems to load it into slot 2, I think. So this, remember, will be a number or an object or whatever. And then it's going to test less than R0. No, sorry, I've got that backwards. It's going to load those onto that argument. It's going to load those on, test it, pop it off. That's what's happening there. And then that's going to get loaded on. It's going to test is R0 less than that, and the answer is no, because now we've got the type mismatch. And that's what's important here, is they're not actually doing the comparisons. The number comparisons, I know it's only 2, it looks like there are, but they're not doing the comparison, which is a very, if I then do this to D as well, let's just check that is how I'm interpreting that correctly. Ooh, ooh, compiler error. Here again, you can see you're comparing the result, not comparing the next pair. That's the fundamental difference between the Python and the JavaScript. Even though I can't go to the same depth of interpretation of this as I would do in Python, that's why it doesn't go on. So basically what we can say here is that the output of this is really the equivalent of saying if A is less than B is less than C, is saying, well, take A and B, and then is that less than C? Which is a completely different answer to is A less than B and is B less than C. And it's a fundamental difference in the language structure. And I'm really interested now, this is where the nerd sniping takes in, and why I've been sitting there for 10 days doing it, sitting there going, I wonder what C# does, I wonder what Java does, I wonder what the language specification actually says for what should happen when you have multiple steps of comparison to happen. Both languages do stop at the first failure. So I think if you were to go through and do the same experiment that we did for Python, where you have this sort of make an object, override it, you'll see that it wouldn't continue if the answer was false. It does stop. But fundamentally, that's under the hood. That is why. That's another reason why Python is better than JavaScript. It's better than Java as well. That's the answer. And you have to go into the bytecode to realise that actually definitely is comparing the result rather than the entry. You can demonstrate that with this kind of thing, but it's hard to prove it because even though I've got the comparison of B and C here, you don't know there's necessarily a comparison of A and B, or there isn't a comparison of C and D and so on. So the order of operation matters, the actual way you're interpreting the language matters, the language spec matters to a degree. The JavaScript spec is very, very long-winded, and I haven't gone through it. I am going to read this later when I decide to go to bed and just like I need some quiet to read. Oh, I'll read the JavaScript language specification. But I've got to actually find the binary logical operators. There's difference in binary logical operators and normal logical operators, so I've got to go through this and actually find which one I actually want to care about. But it's nice. To be honest with you, I quite like how the JavaScript language spec is actually written out. It is a bit written by committee, it's a bit over the top, but I do like it because it's very factual. The Python one sometimes is more, oh, here's the Python functions and here's the Python docs that go with it, rather than telling you actually under the hood what it's supposed to do. But it is what it is. So that's all I've got time for in this one. I realise this was supposed to be a 10-minute video, but I think now it's probably a 20 or 25-minute video. Congratulations if you made it this far. Please hit like, please hit subscribe, please tell your friends. And if you guys, if any of the JavaScript developers actually want to teach me more about how the JavaScript engine works and how the virtual machine works and other versions of the virtual machine, I would be really interested to hear those things. So please let me know either on Twitter @jmons, that's my Twitter ID, or hit me up in the comments and let me know. That's it for now. Thank you very much. Hit like, hit subscribe. See you all next time.